topic we'll be discussing in this lecture is cellular systems. Cellular systems for mobile communications are basically implemented by using SDM, that is space division multiplexing. Because here each transmitter is typically called as a base station, and the base station covers a certain area of a cell. The radius of the cell can vary from several tens of meters to tens of kilometers. That is, if the base station is within a building, then it may cover several tens of meters. In cities, it may cover several hundreds of meters. And in countryside, it may cover up to several tens of kilometers. The shape of the cells are normally represented by using a hexagon, but it need not be a hexagon or a perfect circle in the real world. In the real world, actually, the shape of the cell depends on the environment. The shape of the cell depends on the environment. So, environment in the sense it includes buildings, mountains, valleys, etc. Whatever there in the environment. So, depending on the environment, the structure of the cell will change. For example, in a mountain environment, the cell structure will be something different, and in between buildings, if there are more buildings in the area where the cell is located, then the structure of the cell will be different. Okay, so basically it depends on the environment, on weather conditions, and also sometimes it depends on the load on the systems. So weather condition may also influence the structure of the cells. Okay, so if the weather is very hot, or if the weather is very cold, or if the weather is rainy, so accordingly the cell size may vary. Similarly, if the load is high or if the load is low, then also the cell size may either shrink or it may become bigger. Okay, so the cell size is always, it will not be a hexagon or a circle form. For understanding theoretically in textbooks or in any learning materials, it is represented in the form of hexagon or circle, but in real life it need not be, in real time it need not be so. Okay, so right, so mobile station within the cell around a base station communicates with this base station. Okay, so mobile stations in the sense mobile phone. Mobile station means mobile phone. The mobile phone that are within the cell around a particular base station will communicate with that particular base station, and the base station also in turn will communicate with the respective mobile device. Okay, so this is how actually the basically the cellular communication works. That is, each base station will cover a certain area, and that area is called as cell, and whichever the mobile station comes within that particular area or that particular cell will communicate with that particular base station, and in turn that base station also will communicate or will respond to that particular mobile phones. Okay, that is, each base station will cover one area, and that area is called as cell, and the radius of the cell, it varies from several tens of meters to several tens of kilometers, depending on where the cell is located or it is uh, placed. Okay, so this is the a basic introduction to cellular system. And now let us try to understand like why should we have so many base stations? What is the need to install so many base stations? Why there are several thousands of base stations were installed? If you take the example of radio stations, there is only one radio station for each channel, and it is broadcasting its information using a powerful transmitter throughout the state or throughout the country or whatever it may be. Why can't we have such a system for mobile phones? Why can't we have such a system for mobile phones? Why should we? Why should each service provider should spend so much money on installing several thousands of base stations? So there are certain reasons. So let us try to understand the reasons. So what are the advantage of having cellular systems with small cells? Small cells in the sense each base station will form one cell. So what is the advantage of that? So that let us try to understand. So the first advantage is higher capacity. Okay. So implementing an space division multiplexing allows frequency reuse. So if there are more base stations, then what does it mean in the sense? The base station covers only a limited area. So whatever the frequency is used in that particular base stations can be reused in the coverage area of another base station. Okay. So if one transmitter is far away from another, that is if one base station is far away from another, and if they are outside the interference range, if if the two base station they don't the signals from the two base stations, if they are not interfering with each other, then the signals can be reused. Then the signals can be reused. Most of the mobile phones systems are assigned frequencies to certain users. Okay, so this frequency is blocked for other users. So in some cases, in some of the mobile phone systems, what happened in the sense, certain frequencies are blocked for certain users. Okay, but actually frequency is a scarce resource. So it means that these frequencies are blocked for other users. Okay, so in that case, number of concurrent users per cell is limited. If you say that this frequency is for this user, that this frequency is for some other user, if you differentiate like that, then the number of concurrent users will be limited because you have only very limited set of frequencies. The frequencies are not under the control of the system. Rather, once it is allocated, it is for that particular person. Okay. So huge cells do not allow for more users. Generally, if the cell size is huge, it won't allow for more users, but they are limited to uh, they are limited to less possible users per square kilometer. Okay, so this is also the reason for using very small cells in cities, right? Because the number of users within a cell is limited, so we have a better control. Okay? If everybody comes under one base station, that is if you have only one base station for the entire country India, or if you have only one base station for the particular state, then what will happen in the sense managing these users uh, within one base station is also very difficult. Okay, so the key takeaway point is first is why we have several base stations instead of one in the sense because of the first heading higher capacity. So here what we discussed in the sense one is frequency reuse, one is frequency reuse, and another one is when you divide into multiple base stations, the number of users per base stations will be limited, so we have a better control. Okay. Next is less transmission power. What does it mean? So transmission, so the power aspect is not a problem for base station. Okay. But actually power is an issue for mobile phones. Okay. And a receiver who is away from the base station. The receiver who is away from a base station needs more power, needs more power. Okay, so so if there are more users in a particular base station, uh, then the service may not be effectively provided for the user who are away from the base stations. Okay, that is also one of the reason why we have multiple base stations. Because if you have multiple base station, what happens in the sense, the number of users in that base station will be comparatively less. Okay? So even though if a user is away from the base station, uh, by spending more some extra power, he'll be able to connect with the base station. That is the second reason why should we have several thousands of base stations instead of one base station. The third reason is local interference only. So, so, so if you have only one base stations, then there will be interference from all the users, because every user will be connected to this one base station. Okay, so but if you have many base stations, then for each base station there will be a limited number of users. So so the signal will get interfered only by these users. Okay, so basically having long distance between sender and receivers uh, result in more interference problem. Okay? So if you have only one base station for the entire country, then there will be more interference problem. With with small cells, mobile stations and base station only have to deal with the local interference. So dealing with the local interference is comparatively easier. Okay. The next is robustness. So what is meant by robustness? So robustness means cellular systems are basically decentralized. So more robust against a failure of single components. So if there is only one base station throughout the country, and if that base station fails, then the entire users who are using that particular service from the mobile from that particular base station, they all will not be able to communicate. But that is not the case if you maintain multiple base stations. Even if one base station fails, the others will work. Okay, and also in some cases the other base station can compensate for the users coming under in this base station also. Okay, right. So if one antenna fails, this only influence the communication within a small area. So these are some of the reasons why we should have multiple base stations instead of a single base station throughout the country. Okay. So there are also some of the disadvantages of for having multiple base stations. So let us try to analyze those disadvantages. So the first disadvantage is infrastructure is needed. We need if you want to have thousands of base stations, then obviously some infrastructure is required. Okay, and cellular systems generally require complex infrastructure to connect all the base stations. So because you may have to install many antennas, switches for call forwarding and for other tasks. Okay, so basically the whole system may become more expensive. This is one of the disadvantage. The second disadvantage is handover is required. If a user is moving, if a user is moving, then obviously after a period of time he will reach a point where he may lose the connectivity with his base station. So in that case, his mobile phone should be connected with the another base station in which place where he is going. So that process is called as handover. So whenever mobile station, so in this case, if there are thousands of base stations, the handover has to be performed effectively. But if there is only one base station for the whole country, then there is no question of handover. So depending on the cell size and the speed of movement, depending on the size of the cell and the speed at which the user is moving, Depending on that, this handover may occur either more frequently or less frequently. Okay. And the next disadvantage of having many base stations or small cells is frequency planning. So to avoid interference, to avoid interference between transmitters using the same frequencies, frequency have to be distributed carefully. Frequencies have to be distributed carefully. Um, so we should avoid frequency and also there are also limited number of frequencies available, but also we should avoid interference. Interference should be avoided, but at the same time, the number of frequencies available were also limited. So these are the disadvantages of having multiple base stations instead of a single base station. Next thing what we'll be discussing is to avoid interference. Okay. So what one of the technique that is followed is different transmitters within each other's interference range. They can use FDM. If there are more than one transmitters and if they are falling in their interference range, okay, if there are more than one base station and if they are falling in an interference range, then they can use FDM, frequency division multiplexing. That is as they are interfering with each other, each user, okay, each user or each cell may work on different frequencies. Okay, that is called as frequency division multiplexing. Otherwise, you can also use a combination of frequency division multiplexing and time division multiplexing, as we have discussed sometimes earlier. And if you use frequency division, if you use the combination of frequency division multiplexing and time division multiplexing, then the hopping pattern should be coordinated. So here the general goal is never to use the same frequency at the same time within the interference range. So two possible models are available for cell patterns with minimum interference, that is shown here in the diagram. So the first pattern here you can see, here there are mm, here three cells were combined to form a cluster. You can see three cells were combined together to form a cluster. For example, this is one cluster, F1, F2, F3. Okay. So like this is another cluster, F1, F2, F3. Like that, every three cells, they this is another cluster, F1, F2, F3. Okay. This is another cluster. Okay. So like that, three cells they form a cluster, right? So and in the right side figure, what happens in the sense, seven cells form a cluster. Okay. So why this type of cluster should be formed? So basically the cells within a cluster, each of the cells use a unique frequency. So if you see this particular cluster, each the cells within this cluster, each cell use a different frequency. One of the cell uses F1, the other use F2, the other use F3. So this clustering scheme can be used for frequency reuse. For frequency uh, reuse. So this pattern also shows the repetition of the same frequency sets. The same frequency sets can be repeated. Okay. Transmission power of the sender has to be limited to avoid interference with the next cell using the same frequency. Okay. The transmission power of the sender should be limited so that interference can be avoided. Okay. And to reduce the interference further, you can use something called as sectorized antenna, which is shown in this diagram. So sectorized antenna can be used to reduce the interference further. Okay. So So this is how interference can be reduced. Okay, either by clustering or by using sectorized antenna. So sectorized antennas can be used to reduce interference even further. Okay. Fixed assignment of frequencies to cell. Uh, if if the frequencies to each cell is nothing but the area covered by the base station. If for the area covered by the for area covered by the base station, it is called a cell. If for each cell, if the frequencies are fixed, then that is not an efficient technique because the traffic load varies. The traffic load varies. So at sometimes some of the what do you call some of the cells, the traffic load may be very high, but for other cells the traffic load may not be that high. Okay. So generally the system should allow to borrow frequencies. The system should allow to borrow frequency because if heavy a load in one cell and light load in another cell, in the sense the the user who needs a heavy load can borrow frequencies from the light load. The user who needs a light load frequency. So this concept is called as borrowing channel allocation. Cells with more traffic are dynamically allocated more frequencies. Okay. So whichever the cell there are more traffic, they are automatically allocated with more frequencies. So fixed channel allocation is a technique which is used in GSM. So GSM is Global System for Mobile Communication. So GSM uses a fixed channel allocation because it is simpler to implement. So implementing fixed channel allocation is very easy. So that is one of the reason why GSM uses fixed channel allocation. But before going for fixed channel allocation, uh, uh, it also demands a careful traffic analysis before installation because you should assign different range of frequencies for different cells. So you should have an idea like in which cell typically there will be more load compared to some other cell, so that that can be allocated more frequencies or better frequencies. Okay. So uh, so 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 that is what is called as fixed channel allocation. Okay. And then we have something called as dynamic channel allocation. The dynamic channel allocation is used in DECT. Okay. Here the frequencies can be borrowed. Okay, the cells can borrow frequencies from the neighboring cell. Okay, this is how uh, dynamic channel allocation works. Okay. And cellular systems that uses CDM, that is code division multiplexing. If the cellular system is using CDM, code division multiplexing, and not FDM or TDM, then they do not need elaborate channel allocation scheme and complex frequency planning because these are separated by codes. Okay? Because here users are separated by code, and higher the noise, higher the path loss. So for any signal, if the noise is more, the signal is encountering through more noise, then there is a chance for more path loss, and also there is a chance for high transmission errors. So 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 we should ensure that the noise is suppressed or removed as much as possible. Okay. And 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 also what happens in the sense, the mobile phones that are further away from the base stations, naturally they drop out of the cell. The mobile phones that are away from the base stations, they will drop out of the cell. That is shown by this diagram. So here what you can observe in the sense, this is a base station and there are many mobile phones connected with the base station, and this is the transmission range of the mobile phone. Okay, so in this range the transmission or the signal is received in a very good way, but in the outer range it is not that good, it is little weak. Okay, but during this time, say for example, one of the user, if this particular user, if he is demanding an high speed video, if he is requesting the mobile station, sorry, base station, if this user is requesting the base station to download a digital video, okay, to download a high definition digital video, then what happens in the sense, the base station has to provide more bandwidth for this user. The base station should provide more bandwidth for this particular user compared to other users. So because of that, what may happen in the sense, these two users who are little out of that communication range, these two users who are little out of the communication range, uh, they may get disconnected. They may get disconnected. Okay, so so this is the so this is what this diagram says. Okay, so this additional users lets the shell to shrink. Okay, because this user is demanding an high speed video content, so which allows the cell size to shrink. So basically this is the cell size, this is the cell size of this base station, but the size of the cell shrinks. Okay, because of uh, because of the demand of an a high speed video by one of the user. So that's it about cellular systems. So basically, in cellular systems, we have discussed several things like, so we have discussed that cellular system uses SDM, and we have discussed that the area is covered by the base station is called as cell, and we have understood that the cell need not be circle or hexagon. Actually, the size of the cell is affected by various environmental weather conditions and other factors. Okay. Then we have discussed the advantage of cellular systems. Okay. So the advantages what we have discussed is higher capacity. So in the sense, we can use frequency can be reused if you have multiple cells instead of one single common base station. The frequencies can be reused. Okay, and also huge cells do not allow for more users. The number of users per base stations also will be less, which is manageable. Okay, and also the next reason is it needs less transmission power. Needs less transmission power. Okay, so if there is a user, so it is difficult if there is only one base station, say that base station is located in Delhi, then how much power your mobile phone needs to communicate with that base station. Okay, but if there are many base stations, then your mobile phone can easily communicate with the base station, because at least you can find a base station within a radius of 5 kilometers or more, or normally generally. Okay, fine. And then local interference, that is these signals, that is the mobile phones within the particular cell should only go through local interference. It need not go through the interference from all. Okay, but if you have only one base station, then you have to face the interference of everyone, okay? Every other signal. And robustness, cellular systems are decentralized, okay, and so robust against the failure of single component. If one particular component fails, the entire system will not fail. That is what is called as robustness. Okay? But then we have discussed the disadvantages of disadvantages of cells. Okay, and then we have discussed like how interference can be avoided by using several techniques that we have discussed. Okay, uh, so how clusters are formed. So we discussed like one network with three cells forming a cluster, and another network with seven cells forming a cluster. Okay, and using sectorized antenna also, the using sectorized antennas also the interference can be reduced to a larger extent. Okay. And then finally we have discussed that in CDM, if you are using CDM, uh, then you do not need elaborate channel allocation scheme or complex frequency planning. All these are not required for CDM. It is if the system uses code division multiplexing, then those things are not required. And finally, we have discussed like how the how one of the user may get disconnected if if other users demand more content. How the cell size get shrinked. Okay, so that we have discussed with an example in this diagram. Right. So that's it about cellular systems, and and also that's it about this particular session, which is wireless transmission. So now let us have a brief summary of whatever we have discussed so far under wireless transmission. So under this heading wireless transmission, so initially we have discussed the frequencies of radio transmission. Initially, we have discussed the frequencies of radio transmissions. So under basics of wireless communication, we have discussed the frequencies. Like what are the various frequencies? We have discussed from very low frequencies to extremely high frequencies, and different frequencies for communication of different informations. So we have understood that a long wave can penetrate through obstacles, that is long wave in the sense low frequency waves. Okay, whereas short waves like high frequency waves will be get absorbed by the obstacles. Okay. And then we have discussed antennas. We have discussed different types of antennas like omnidirectional antenna, bipole antenna, and directional antennas. So like that, we have discussed many types of antennas and its features. Okay. And then we have discussed the effect of the signal. When the signal is passed through an through the wireless media, how it get affected. Okay. So basically, even in the free space, the strength of the signal will reduce proportional to 1 by d square. D represents the distance that we have discussed. Similarly, the signal may also go through other effects like shadowing, reflection, diffraction, scattering, etc. Okay. Shadowing means when the signal hits the object will absorb the signal and it will not leave anything. So that is called as shadowing. Okay, shadowing happens if the size of the signal, if the size of the object is greater than the wavelength of the signal. Okay. Then we have discussed reflection. So reflection means if the when the signal hits that object, it will be reflected back. So this happens if the size of the object is less than the wavelength of the signal. Okay. Similarly, we have also discussed diffraction. Okay. So which means if the signal hits at the edge of an object, then it may get diffracted. And also we have discussed scattering. Okay. We have also discussed scattering. So scattering happens if the mm, so scattering happens if the size of the object is less than the wavelength of the signal. Reflection and shadowing happens if the size of the object is more than the greater than the wavelength of the signal. Okay. So previously I said reflection, the size of the object is less than the wavelength, but that's not the case. For reflection and shadowing, the size of the object should be greater than the wavelength of the signal. Okay. So this is the effects of the signal, and then we have discussed multipath propagation. So with multipath propagation, the signal will arrive with a time delay. The signal will arrive with a time delay through different paths, and because of that, it may create a problem called as intersymbol interference. That we have discussed, and also we have discussed that the intersymbol interference can be rectified if the sender and receiver are fixed by um, by using a compensator. Okay, but if the sender and the receiver are moving, then how can you fix that, then that is really a challenging thing. So normally in radio communications, what happens in the sense, while traveling, if you try to listen to the radio, the signal will get disturbed because the receiver is keep on trying to adapt to the right frequency, so the signal is getting disturbed. Okay, so 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 those concepts we have discussed, and then uh, uh, we have uh, we have also uh, yeah, we have discussed multiplexing techniques, various multiplexing techniques like space division multiplexing, frequency division multiplexing, time division multiplexing, and code division multiplexing. And what are the advantage and disadvantage of these techniques? When which technique should be used? All these things we have discussed. So under time division multiplexing, under time division multiplexing, we have also discussed that time division multiplexing can also be used along with frequency division multiplexing. Then we have discussed different modulation schemes. Okay, so that is digital signal. If you want to transmit the digital signal through the wireless media, then you cannot transmit the digital signal directly. It should be modulated. So first you have to convert it to analog signal. For that, we have to use a technique called digital modulation. So we have discussed various digital modulation techniques like amplitude shift keying, frequency shift keying, phase shift keying, and also we have discussed concepts like advanced frequency shift keying. Okay, under under advanced frequency shift keying, we have discussed minimum shift keying. Similarly, we have discussed advanced phase shift keying. Under advanced phase shift keying, we have discussed QPSK, quadrature phase shift keying, and QAM, quadrature amplitude modulation. So and also we have discussed 16 QAM, how 16 QAM can be done. Okay. So these are the various concepts we have discussed. And also we discussed that it is just not enough to perform digital modulation by using ASK, FSK or PSK, but the resultant signal should also be modulated using analog carrier. Then only the signal will be converted to a high frequency signal, and then it can be transmitted. So directly after converting it to an analog signal, you cannot, the analog baseband signal cannot be transmitted as such because of various reasons like the length of the antenna uh, and other reasons we have discussed. Okay, so that is what we have discussed under modulation. So these are the different modulation schemes we have discussed: ASK, FSK, PSK, advanced FSK, and advanced PSK. Okay. Following that, we have discussed spread spectrum. So, so the signal can be spreaded across the frequency domain, and then it can be transmitted. So basically, spread spectrums are used to reduce the narrowband interference. Okay, so how it reduces the narrowband interference, that we have discussed through two techniques. One is DSSS, there is direct sequence spread spectrum, and the other one is FHSS, which is frequency hopping spread spectrum. Okay, so in a so so basically, in a direct sequence spectrum, the input signal will be XORed with a chip sequence. The input signal will be XORed with a chip sequence. Okay, the input sequence will be of longer duration, whereas the chip sequence will be of shorter duration. So, and the resultant signal will be modulated, and then it will be transmitted. Okay. Whereas in frequency hopping spread spectrum, the entire bandwidth will be divided into multiple smaller frequencies, and then we have discussed two types of FHS: the short FHS and long FHS. With short FHS, the the transmitter or the receiver will use the same frequencies for multiple user data. Okay. whereas in case of uh, fast 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 hoping, what happens in the sense, the the sender, the transmitter or the receiver will switch from one frequency to another frequency just for transmitting one data of the user. Okay, so this is how spread spectrum works. And then finally we have discussed the cellular systems. So how cellular system works, what is a cell, why should we have so many base stations, and how interference can be avoided, what is the advantages of having many base stations over one base station, what is the disadvantages of having not having one base station. Okay, and how sometimes a user may uh, get disconnected from a cellular phone, cellular network. Okay, so all these things we have discussed under cellular systems. Okay, so that's it about the topic wireless transmission. So let us stop here. Thank you.